In this episode, we move from the moment an AI system goes live to what happens next, because the real test of responsibility is not whether something launches successfully, but whether it stays safe and reliable in the messy world of changing data and changing behavior. Monitoring is the discipline of watching an AI system closely enough that you notice problems early, understand what is happening, and respond before small issues grow into customer harm or business disruption. For brand new learners, it helps to think of monitoring as the dashboard and warning lights in a car, because a car can be built perfectly and still become dangerous if you never notice overheating, low oil, or failing brakes. The audit lens is important here because teams can claim they monitor, but an auditor asks what exactly is monitored, how often it is checked, who is accountable, and what happens when something looks wrong. AI introduces special monitoring challenges because the system can change in effect even when the code does not change, simply because the world that feeds it changes. By the end of this lesson, you should be able to explain drift, performance, and incident triggers in plain language, and you should understand what evidence an auditor expects to see when verifying monitoring controls. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Monitoring starts with a basic truth that surprises many beginners. An AI model is not a static product. It is a relationship between a model and the data it sees, and that relationship can shift over time. Traditional software typically behaves the same way today as it did yesterday if the inputs are the same, but AI systems often rely on patterns and data that can evolve as users change their behavior, markets shift, fraud tactics adapt, or new products are introduced. This is why monitoring is not optional. It is the mechanism that detects when yesterday's assumptions no longer match today's reality. An audit of monitoring controls looks for intentional design, meaning the organization identified what could go wrong, selected measurements that would reveal those problems, and connected those measurements to decisions and actions. Beginners sometimes treat monitoring as a single number like accuracy, but real monitoring is a set of signals that together tell a story about whether the system is still behaving as intended. If those signals are missing, or if they exist but no one pays attention, then the organization is effectively driving without looking at the road. One of the most important monitoring concepts is drift, which is a word that describes change that happens gradually, sometimes so slowly that people fail to notice until the impact becomes obvious. Data drift is when the input data begins to look different over time than it looked during training or testing, like when customer demographics shift, device types change, or new categories of behavior appear. Concept drift is when the meaning of patterns changes, such as when fraudsters learn to mimic legitimate behavior, causing the relationship between features and outcomes to shift. For a beginner, it can help to imagine a spam filter that was trained when most spam looked like obvious junk, but then spammers learned to write messages that look like normal business emails, which means the old patterns become less useful. Auditors care about drift because drift can quietly degrade decision quality, increase unfair outcomes, or create safety issues without any dramatic event to signal the change. A strong monitoring program includes drift detection signals that are defined in advance, measured consistently, and reviewed by accountable owners. To make drift measurable, organizations typically monitor characteristics of inputs and outputs, not just final outcomes. Input monitoring might include tracking distributions, ranges, and missing values for important fields, because sudden shifts can indicate a broken data feed or a real-world change that affects model behavior. Output monitoring might include tracking how often the model chooses certain classes, how confident it appears, or how frequently it sends decisions into a particular bucket, because output shifts can be early warnings that something is changing. The audit question is whether these measures are chosen thoughtfully, because monitoring random statistics is not the same as monitoring meaningful risk. Auditors also want to see baselines, meaning reference points that represent normal behavior, because without baselines it is hard to tell whether today is unusual. Another important audit concern is whether drift alerts are tuned appropriately, because alerts that trigger constantly become noise and get ignored. while alerts that never trigger are not providing protection. Good monitoring balances sensitivity with practicality, and an audit evaluates whether that balance is intentional and evidence-based. Performance monitoring is the next pillar, and it is broader than just whether the model is accurate in a laboratory sense. Model performance includes predictive quality, but it also includes operational reliability, such as whether the system responds quickly enough, fails gracefully, and remains available under normal load. For example, an AI system might technically make good predictions, but if it times out during peak usage, it can cause backlogs, delays, and poor customer experience. In addition, performance must be evaluated in context, because an AI model used for low-stakes recommendations may tolerate more error than one used for safety, eligibility, or financial decisions. Auditors ask whether the organization monitors the metrics that matter for the use case and whether it understands acceptable ranges for those metrics. A common failure is to monitor only technical metrics while ignoring business impact, which leads to situations where the model looks fine on paper but creates real problems in practice. Strong performance monitoring connects the model's behavior to the outcomes the organization cares about, while staying careful not to overclaim certainty. Another beginner-friendly way to understand performance monitoring is to separate leading indicators from lagging indicators. Leading indicators are signals that problems may be forming, like rising uncertainty scores, increasing rates of manual overrides, or growing disagreement between the model and human reviewers. Lagging indicators are outcomes that show harm has already occurred, like customer complaints, increased incident tickets, or measurable financial losses. Auditors want to see leading indicators because relying only on lagging indicators means the organization learns about issues after impact. This is especially important in AI because certain failures can propagate quickly, affecting many people before anyone notices. Performance monitoring should also include segment-based checks, meaning the organization looks at how the model behaves across different types of cases, because an average number can hide serious problems in a minority group or a specific scenario. The audit mindset is to look for hidden risk, so segmentation and targeted analysis become part of the monitoring evidence. Now we arrive at incident triggers, which are the bridge between monitoring and action. A trigger is a defined condition that, when met, requires a response, such as escalating to a responsible team, switching to a safer mode, or halting certain outputs. Without triggers, monitoring becomes passive observation, like staring at a thermometer without deciding what temperature counts as dangerous. Incident triggers can be technical, such as a spike in error rates, a sharp drift signal, or a collapse in predictive quality, but they can also be governance-driven, such as the discovery of a new regulatory constraint or a credible report of harmful outcomes. An audit examines whether triggers are defined in advance, because trigger definitions created during a crisis tend to be inconsistent and politically influenced. Another key audit point is whether triggers are tied to owners and timelines, so the system does not sit in a degraded state while people debate what to do. For beginners, it is enough to remember that triggers transform data into decisions, and decisions are what protect users. Incident triggers also need severity levels, not as a fancy framework, but as a practical way to avoid treating every alert as an emergency. If every trigger demands the same response, teams either overreact and burn out, or they underreact and miss real danger. A better approach is to define different classes of triggers, such as warnings that require investigation and critical triggers that require immediate action. An auditor will look for evidence that these classes exist, that they match the use case risk, and that the organization has practiced responding to them. Practice matters because in an incident, people revert to habits, and if they have never rehearsed how to pause or roll back an AI capability, they may hesitate or make rushed choices. Another subtle audit concern is whether incident triggers consider both false positives and false negatives, meaning whether the system triggers too often for harmless noise or fails to trigger when harm is building. The goal is a monitoring and trigger system that is trusted because trust drives action. A critical part of monitoring controls is the feedback loop, meaning how monitoring results lead to changes and how those changes are tracked. If monitoring reveals drift, the organization might retrain a model, adjust thresholds, refine data validation, or add new safeguards. But the audit question is whether those changes follow controlled processes rather than ad hoc tweaks. This is where monitoring intersects with change management, because the act of fixing can introduce new risk if it is rushed or undocumented. Auditors will look for records showing what was detected, how it was evaluated, what decision was made, and what was changed, because those records prove governance is working. Beginners sometimes assume monitoring is purely a technical task, but it is also a management task because someone must decide what the signals mean and what to do about them. Strong monitoring controls include clear reporting paths, scheduled reviews, and documented decisions that demonstrate responsible oversight. When those elements are missing, monitoring becomes an afterthought rather than a control. Monitoring must also cover the full pipeline, not just the model, because many failures originate in data handling and integration. If a data source changes format, values can become misread, categories can get swapped, or missing data can appear, and the model's outputs may degrade even though the model itself is unchanged. Auditors therefore look for data quality monitoring, such as checks for completeness, plausibility, timeliness, and unexpected spikes or drops. They also look for monitoring of pre-processing steps that transform raw inputs into features, because errors there can systematically distort what the model sees. Another aspect is monitoring for security and access anomalies, because if an attacker manipulates inputs or a pipeline is tampered with, model behavior can shift in ways that resemble drift but are actually malicious interference. For a beginner, the key idea is that AI systems rely on many moving parts, so monitoring must be holistic to catch problems where they actually emerge. A narrow focus on the model alone can create blind spots that defeat the entire purpose of monitoring. It is also important to understand that monitoring controls need to be appropriate to the risk and the pace of change. A system making frequent decisions in a dynamic environment may need near real-time monitoring and rapid triggers, while a slower, low-stakes system might use periodic reviews. Auditors will evaluate whether monitoring frequency and detail are justified by the potential impact of failure, because monitoring that is too slow can allow harm to accumulate. Another risk-driven factor is the ability to intervene, because monitoring without the ability to pause, route to human review, or revert to a safer mode is like having a smoke detector that cannot wake anyone up. Monitoring controls should include escalation pathways and operational authority, meaning the people receiving alerts can actually take action rather than merely report issues upward. This is often a hidden weakness, where alerts go to teams that do not have the power to change anything, causing delays. A strong audit will test these pathways through evidence of prior incidents or drills that show the organization can respond quickly. A common misconception among beginners is that monitoring is only about catching failures, when it is also about building confidence that the system is behaving well. When monitoring shows stable inputs, consistent outputs, and acceptable performance across segments, the organization can justify continued use with evidence rather than optimism. Another misconception is that monitoring is solved once dashboards exist, but dashboards do not protect anyone unless they drive decisions, and decisions do not happen unless responsibilities and triggers are clear. Auditors are not impressed by sophisticated charts without accountability, because the goal is not visualization, it is risk control. Monitoring also should not be confused with surveillance of people. It is focused on system behavior, quality, safety, and compliance with expectations. If monitoring is framed as blame, teams will resist it, but if it is framed as safety, teams will use it to learn and improve. The mature view is that monitoring is part of operating AI responsibly over time, not a temporary step after deployment. To tie these ideas together, imagine an AI system that helps decide which customer requests should be reviewed for potential fraud. If the world changes and fraud patterns shift, drift monitoring might detect that the input patterns or output rates are changing, even before confirmed fraud outcomes are available. Performance monitoring might show that confirmed detection rates are dropping or that manual reviewers disagree more often, which suggests the model is less aligned with reality. Incident triggers might define that if disagreement crosses a threshold or if a certain class of suspicious behavior spikes, the system must route more cases to human review or temporarily disable automated decisions. An auditor would ask whether these signals were defined ahead of time, whether baselines existed, whether alerts reached the right owners, and whether the response was timely and documented. The value of this example is that it shows monitoring is not abstract, because it affects whether people are falsely accused, whether fraud is missed, and whether customers are treated fairly. Monitoring is how the organization notices, explains, and corrects these issues before they become scandals. When you step back, auditing AI monitoring controls is really about verifying that the organization has built a living safety system around its model. Drift monitoring checks whether the environment is shifting in ways that can undermine assumptions. Performance monitoring checks whether the model is still delivering the intended value without hidden harm, and incident triggers turn detection into action with clear accountability. These controls are not just technical choices, because they reflect governance, ownership, and the willingness to respond decisively when evidence demands it. For a brand new learner, the most important lesson is that AI systems require ongoing attention, and that attention must be structured, measurable, and connected to decisions, not left to occasional intuition. When monitoring controls are well-designed and well-audited, they make it possible to operate AI with confidence while reducing the risk of silent failure. If you can explain how drift, performance, and triggers work together, you are building the core mindset that Task 8 expects, proving that an organization is not merely deploying AI, but responsibly operating it over time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.